Now you have seen the methods for verifying some trig identities. In this video, we will look at this identity which can be verified, but that's not main focus of the video. I want to apply this identity. So you have to believe that this identity can be proved to be true. And this is an identity involving two angles, alpha and beta. So cosine of a difference, alpha minus beta, right? Here is the difference for cosine. So we want to look at this version difference formula for cosine. If we can prove it is true, then let's just look at this identity closely. And so we realize this identity involves alpha and beta. And this cosine of the difference is equal to cosine alpha, cosine beta, the product of cosine alpha, cosine beta, plus the product of sine alpha, sine beta. Yeah, so let's use it, apply it to a case. Here, suppose we are looking for the exact value of cosine 15 degrees. And the 15 degrees, 15 is not a special angle. We know some trigonometric function values of special angles, right? So let's see if we can possibly write 15 as, for example, difference of special angles. We can think of 60 minus 45. 60 minus 45, that's 15. So you see 15 can be written as a difference. So now once we have a difference, and we have a difference for cosine, and we can go ahead to use cosine value of 60 and 45 and sine value of 60 and 45 to eventually get this cosine 15 degree. So let's see, the alpha is 60 here. Now beta is 45. So all we need is to, here is 60 minus 45, right? So alpha, beta are respectively 60 and 45. So all we need is to put 60 and 45, then immediately we get so whenever we see alpha, we replace it with 60. Whenever you see beta, you replace it with 45. And alpha 60, beta is 45 degree angle. So with this, we continue, we know the 60 degree and 45 degree, they are special angles, and the trig function values are known to us, right? We already calculated. So let's go ahead, put the values in. Cosine 60 is this number, cosine 60. And cosine 45 is square root of 2 over 2 plus sine 60. Sorry, cosine is half, right? Cosine, because cosine 60 is the sine of 30. Yeah, we know that is, yeah, cosine 60 is half. Cosine sine 60 is square root 3 over 2. And sine 45 is square root of 2 over 2. So the first number, the second number will be, if you multiply numerators and denominators, we get square root of 6 over 4. So together, these two numbers we combine, we get, because they have the common denominator. So that's the answer. This, after we use the cosine and sine values of the 60 and 45, then we can actually get the exact value of cosine 15 degrees. So because 15 is the difference of these two angles. So we have already applied this formula once for a specific case when alpha is 60, beta is 45. But you might want to choose a different pair, right? So you think if I choose alpha to be 45 degrees and beta to be 30 degrees, the difference is also 15 degrees. So yes, you can. If you choose to calculate this cosine 15 degree in this way, that is a 45 degree minus a 30 degree angle. Yes, because the two, the difference of the two, you see, that's still 15. So that's fine. We should get the same answer. So let's go ahead, apply the difference for cosine formula one more time. So difference for cosine, that is a cosine of the first angle times cosine of the other one plus sine of the first, sine of the other. Yeah. And cosine 45 degree, cosine 30 degree, sine 45 degree, sine 30 degree. And then okay, so we get square root of 6 over 4 plus, okay, square root of 2 over 4. Together, we still get, okay, we combine the two fractions, right? They have the common denominator, 4. So we keep the common denominator and then have the answer. Yeah, that's the same as we got before. It should be the same because we're calculating cosine of the same angle, 15 degrees. So it should not affect your final answer. The reason we choose either this or that is because there are special angles. We can know the exact trig function values for those angles. So, and eventually we can get exact function value, cosine value of 15 degree. Yeah, by applying the difference formula for cosine. But be very careful when you apply the difference formula for cosine. Look, you have a difference of alpha and beta. However, this other side is a plus sign. Yeah, this identity is true for n alpha and beta. And just when you apply this identity, be careful that the left-hand side, when this is a difference for cosine, the other side is a plus. It's a sum of the two products. Now, let's look at another problem. This problem, we notice the plus sign this the sum of the product of cosine and the product of sine. So that makes us think of the formula we just learned, right? So let's think this is just like cosine alpha, cosine beta, where alpha is 80 degree. Beta is a 35-degree angle. So yeah, plus sine alpha, sine beta, right? Alpha is 80 degree. Beta is the 35-degree angle. So now we know this is the cosine of the difference. Yeah, so let's write it as cosine what difference? It's 80 degree minus 35 degree. And that is, which is cosine 45. Cosine 45. So we, from the given expression, we don't really know the 80 degree and cosine value of 80 and the cosine value of 35 because they are not special angles. They are not special, so we cannot give exact value of each cosine or sine. However, if we apply this identity, we can write this expression into the difference for cosine. So the difference for cosine, that is cosine of the difference of the 80 and 35. And immediately it becomes a special angle. So in this example, and we can get the exact value, which is cosine 45, square root of 2 over 2. So that's the answer for this expression. That's the exact value of that expression. So solve this problem, we applied the identity this way and to get the final value, which is exact value of the given expression. So far, you see we can use the identity, right? Given the left-hand side, you can replace it with the right-hand side. For the 15-degree angle, for example, I replaced, because 15 is not special, but we use the cosine 45, for example, cosine 45, cosine 30, sine 45, sine 30. Yeah, we can get the exact value of 15. So that application we used from the left to the right. We used the right to get the exact value of this. But sometimes given the right, then we can go from the right to the left because they are identities, right? Either you encounter the right-hand side, you want to replace it with the left-hand side. And sometimes given the form of the left-hand side, you want to replace it with the right-hand side, depending on which is convenient. So the second example, we are given this form, and we don't want it because this cosine 80 and cosine 35, they are not special angles. So then we want to use the left side. So anyway, this is an identity. You can use left form or the form on the right-hand side. So see that identity, we don't want this. Instead, we want to use the cosine of the difference. So this cosine of the difference, because they are identity, right? This one is the same as that one, but this expression is not possible for us to find the exact value of. But as soon as we apply the identity, then this is possible because, yeah, so we apply the identity, we can get the exact value of cosine 45 degree. So that identity, you can use one side to the other or the other side to this, depending on which is what you need. Now you have seen a couple of applications of the formula, the difference formula for cosine. Now we want to think of a very special case. It is the cofunction identity. Here you see cosine of this angle is sine theta. Cosine of this half of pi minus theta is sine theta. When theta is an acute angle, we already verified this identity. But now we want to claim that this is true for any theta. Theta is an arbitrary angle. It doesn't have to be an acute angle. So this is a general statement. It is still true, right? So when theta is acute, we know the cofunction identity. Cosine of the complement of theta is equal to sine theta. But when theta is anything, no matter it's acute or not, it is still true. So let's prove this cofunction identity. It is a difference for cosine. You see, all we need is to replace in this formula, replace alpha with half of pi, beta with theta, right? So let's replace alpha with half of pi, beta is theta. So now we just apply the identity to this specific case when alpha is half of pi, beta is theta. So every time you see alpha, you replace it with half of pi. Every time you see beta, it is theta. So now this formula is just a specifically this identity is now applied to this. To this case, then we start from, right? So we know that half of pi is a very special angle. Half of pi, the sine at half of pi is 1. So this one is 1. 1 times sine theta is still sine theta. And cosine at half of pi is 0. So 0 times anything will be gone, right? 0, this whole thing will be gone. So that reduce the whole thing becomes sine theta. So we have proved, you see, cosine of half of pi minus theta is sine theta. Yeah, this is the clean version of the proof of the cofunction identity. So you see cosine function at this angle becomes the sine function at theta. So this cofunction identity, so right now we can verify already one cofunction identity, right? This is difference using the difference for cosine formula. So that identity is one of the 6 cofunction identities that can all be verified. But right now we verified this cofunction identity. The first one, cosine of this angle half of pi minus theta is equal to sine theta. So you can, in the future, we already know that all 6 cofunction identities are true when theta is an acute angle, right? So you see, when theta is acute, this is a complement of theta and theta, right? Sine of complement of theta is equal to cosine theta. tangent of complement of theta is cotangent theta. See the cofunction identities. But we want to extend that to general theta, to any arbitrary value theta. That means, yeah. So here you can read this as reading measures, right? Half of pi. You see, theta is any real number that is in the domain of the respective functions. So that means this is still true. Yeah. We still have the cofunction identity, but today we apply this one formula to get this one. And in the future, you can verify all the 6. You can verify the other 5 cofunction identities as well. Now, since we know the difference formula for cosine, how do we show a sum formula for cosine? So if we know the difference formula for cosine, that means we can get this identity, right? Cosine of a difference. But the sum, suppose you have a sum, can we get a formula? We call it sum for cosine. Can we do that? The sum is actually a difference if we write the sum into a minus, right? Minus negative beta. This will be a difference. So then we can apply the difference formula for cosine. You see, that's the difference in the middle. So the sum can be viewed as a difference. So we can just simply apply the difference formula of these 2 angles for cosine. And yeah, that is, you see, the sum is simply the difference minus negative of beta. So negative becomes plus. Okay, so we view the plus as a difference. Then we apply the difference formula for cosine. So in this case, the first angle is, you see, cosine alpha, cosine negative beta, plus sine alpha, sine negative beta. So we just simply apply the formula, the difference formula for cosine, right? Because the first is alpha, the other angle is negative beta. So difference of these 2 will be cosine first, cosine second, plus sine first, sine of the second angle. So now what we can do is the cosine of negative beta is same as cosine beta because cosine is even. Sine negative beta is negative sine beta because sine is odd. So this one equals this. But that sine negative beta is negative sine beta. So we can see finally we get a formula of cosine of a sum. Cosine of a sum is equal to this. Very similar, but differ by this sign. See, let's put them together, then you can compare the difference. Cosine of the sum, right? We just proved. Cosine of the sum. Cosine alpha, cosine beta, minus. You see, when this is a sum, the other side becomes minus. Minus sine alpha, sine beta. Okay, so if we apply the the formula. Let's apply the formula to express this angle. Cosine pi plus theta. Cosine pi plus theta, we want to express it as a trigonometric function of theta alone. So here, alpha, beta, you see, respectively pi. So suppose this is my alpha, this is a beta, you see. That's a sum, right? Cosine of a sum. So the first and second angle. So now we just do the cosine pi plus theta is cosine pi cosine theta minus sine pi sine theta. Now, because the pi is a very special angle, so sine pi is 0. We know this is a 0. 0 times anything will be 0, right? This will be gone. Cosine pi. Cosine pi is -1. It's a very special, has a value of -1. -1 times cosine theta is negative cosine theta. So this term is gone, and with -1 times cosine theta is negative cosine theta. So now we have achieved the purpose of expressing the expression as a function of theta alone. You see, cosine theta is the function of theta alone. And this example, let's see what is given, what is asked for. So suppose we have two, okay, so just alpha is an angle in quadrant 2, beta in quadrant 3, right? So alpha in quadrant 2, beta in quadrant 3. So suppose we know the sine alpha and sine beta. Can we find cosine of the sum? Yeah, cosine of alpha plus beta. How do we find this quantity? That's the question. So immediately we want to use the sum, right, for cosine formula. We want to use the sum for cosine formula because we have this cosine of a sum. So that is the formula we hope to use. But in order to use the formula, what we need to know? The formula says, okay, I do this formula, individual alpha and beta, I need to know the cosine alpha, cosine beta, minus sine alpha, sine beta. Yeah, in order to get this, and we know already for alpha, the sine value of alpha. That means this one given. And beta, we also know the sine value of beta. That means this one is also given. So what is not given is the cosine value of alpha, cosine beta. How can we find cosine alpha, cosine beta from the given sine alpha, sine beta? Yeah, so that's the immediate question. So what do you think? Given sine alpha, we can find cosine alpha, right? Because we know the identity, the fundamental identity, one of them is called Pythagorean identity. So we have three of those Pythagorean identities. This is one of those three. And here, this identity involves sine cosine. So if we know sine, we can find cosine. Yeah. So, or if we know cosine, we can find sine. So let's see. If sine alpha is 5/13 plus cosine square alpha is 1. Then what is cosine? Yeah, solve this equation. Solve this equation. You will find cosine. So let's solve it. So that means 5 square, 25, 13 square plus cosine square alpha is 1. So then we subtract both sides of the equation. Yeah, subtract 25 over 169 from both sides of the equation. So we can get cosine square alpha. So which is 169. So this is 1, right? If you write it into a fraction, it's a 169 over 169. Then you can see quickly it's a 144. So take the square root. If a square is this, what's the cosine alpha? Cosine alpha is the quantity whose square is this number. So cosine alpha must be square root of this number, 12 over 13. We just take a square root of that number. So could be positive or negative. Should we keep positive or negative? Remember, alpha is in quadrant 2. If alpha is in quadrant 2, cosine is negative. So this one is correct. That one should be, the positive value should be discarded. So negative 12 over 13. Yeah, so this is the cosine alpha. Similarly, for beta, we do the same. Because we know the sine beta, we can find cosine beta, right? But for beta, you see, sine beta is given as negative 4/5. Sine beta is given, negative 4/5. What is cosine beta? So using the same Pythagorean identity, sine square beta plus cosine square beta is 1. And then you square, that's a 16 over 25 plus this cosine square beta is 1. So we can solve this equation for cosine beta. But first of all, we need cosine square beta, right? Cosine square beta is 1 minus, yeah, you just subtract both sides by 16 over 25. So the so cosine square beta is this number, which is 9 over 25. So take a square root, you will get cosine beta, which is a 3 over 5 or negative 3 over 5. Which one? Remember, beta is in quadrant 3. Quadrant 3 for cosine, negative. Right? So we discard the positive value. So it is negative 3/5. So now we have found cosine beta as well. So now, see, in order to apply the cosine of a sum formula, given sine alpha, sine beta, we have found cosine alpha, cosine beta. And we put those values, right? So then we're ready to apply this formula. Yeah, because we have cosine alpha, cosine beta as well. So we put all the known values. And then, yeah, on the given values, sine alpha, sine beta. Now we're ready to apply this formula to get cosine of the sum. And the two numbers, when you multiply the two cosine values, you get 36 over 65. When you multiply the two sine values, you get negative, but with another negative sign, you see, we will get a positive. Yeah, so then we final answer, 56 over 65. So this is another time, another application of the identities I introduced in this video. So remember, we cosine of a difference or cosine of a sum. So in this video, we focus on two formulas. Started with the difference, which is cosine alpha, cosine beta, plus sine alpha, sine beta. And then we derive from the cosine of a difference, we got this formula, cosine for the sum, right? Just by rewriting the sum into a difference. So we can get this formula. And that when it's a sum, you have look very similar, but they're definitely different. You see cosine of a sum is cosine alpha, cosine beta minus sine alpha, sine beta. Okay, so two important identities. That is cosine of a difference, cosine of a sum.